When a mountain of rock and ice rips through our sky at 40,000 miles an hour, we expect a catastrophe. In 2013, a football field-sized meteor streaked across the morning sky over Chelyabinsk, Russia. It detonated roughly 19 miles above the surface. The resulting shockwave blew the roof off this brick factory, damaged thousands of surrounding buildings, and sent 1,500 people to the hospital. We are conditioned to view these space rocks as villains, but if you remove them from our history, you remove the conditions for our own survival. Rewind 4.5 billion years, and asteroids stop looking like threats. They appear as the architects that built our world. 4.5 billion years ago, a massive Mars-sized asteroid named Theia slammed directly into a fledgling Earth. The force of the impact blasted a ring of debris into space that eventually became our moon.
It also stabilized Earth's erratic axial tilt, creating the predictable climate and tides that life eventually grew to rely on. A billion years later, a meteorite the size of 4 Mount Everests crashed into what are now the rolling hills of South Africa. For the young water world, this strike functioned as a massive, unintended delivery of essential nutrients. The strike triggered tsunamis that churned up deep-sea iron and brought it to the surface. Simultaneously, the asteroid itself dissolved, dumping massive amounts of phosphorus into an ocean that was previously starving for it. Earth's early history suggests that biological progress often follows in the wake of this specific kind of geological violence. As life grew more complex, the planet's tolerance for these impacts dropped. The same events that once fertilized the oceans began to act as reset buttons. This satellite view of the Yucatan Peninsula highlights the underwater shelf where the Chicxulub crater remains buried. 66 million years ago, a mountain-sized asteroid struck these shallow waters. Animals near the impact site were instantly killed. The collision launched 30-foot mega tsunamis across the oceans, while molten rock was thrown into the upper atmosphere, raining back down to ignite global wildfires. But the long-term extinction was caused by a thick cloud of sulfur and soot. It blocked the sun for months, halting photosynthesis and causing the global food chain to collapse from the bottom up. 70% of all species, including most dinosaurs, were gone. It is a reminder that complex life exists at the mercy of cosmic timing. 35 million years ago, another strike proved how rapidly geography can change, and how effectively the Earth hides the evidence. Look at the peaceful coastlines of modern-day Virginia. Right beneath this bay, an asteroid up to 8 miles wide carved a crater 53 miles across into the coastline. The evidence vanished immediately. Tsunamis washed back over the site, filling the hole with sediment in 30 minutes. The crater remained hidden until 1983, when drills pulled up a layer of molten glass tektites buried deep beneath the modern seafloor. Earth's active geology erases its own history of impact, which can create a false sense of security about how often these events occur. This deep scar in the Arizona desert is the 50,000-year-old Barringer Crater, the best-preserved impact site on our planet. For decades, scientists attributed structures like this to volcanoes. Barringer was the first site where humans proved a crater could be caused by an object falling from space. But we soon discovered that catastrophic strikes don't always leave a permanent hole in the ground. In 1908, a 100-meter-wide rock exploded mid-air over Siberia. The heat flash disintegrated the asteroid before it hit the ground, sending a shock wave through the atmosphere. The explosion left 80 million flattened trees, their trunks snapped and pointing away from the center of the blast. Sites like Barringer and Tunguska changed our perspective of the sky, transforming it from a static backdrop into an environment of ongoing physical threat. To see the true volume of bombardment the Earth has endured, you only have to look at the moon. Without weather or oceans to hide the evidence, it displays every strike it has ever taken. These collisions have the capacity to end an era of complex life, or deliver the chemicals that allow a new one to begin. We are the descendants of this cosmic chaos. The difference between an asteroid acting as a creator or a destroyer is simply a matter of when it arrives.